Welcome back. The objectives of this video are to analyze some more rational functions. So in example 3 here, we're going to use the equation for f of x and graph the function to analyze it completely. Well, we already have the graph over here to the right, but we can see in our factored form that the x minus 3's are going to cancel, so we already know that we're going to have a hole at x equals 3. We also know in our denominator that we're going to have a vertical asymptote at x equals -3. And that corresponds to what we have on our graph. So we've got our vertical asymptote at x equals -3. Our remaining function, or our simplified form of our function, after we cancel, will just be f of x equals 3x plus 1 all over x plus 3. So we need to find the coordinates of our hole and find out exactly where that is. Well, we do that by substituting 3 into the remaining function, f of 3. So we have 3 times 3 plus 1 all over 3 plus 3, and we get 5/3. So our hole is at the location 3 and 10/6, or 3 5/3. So, and that does seem to correspond with what we have in our graph. Also, looking at our function 3x plus 1, if we set our numerator equal to 0, we would find that we have an x-intercept at 3x plus 1 equals 0. So that would be at x equals -1/3. So we can see on our graph, sure enough, our graph does seem to pass through that point, -1/3, 0. So another point of analysis in our function. The domain in our function, well, our domain is all real numbers, although we have to leave out -3, our vertical asymptote, and the location of our hole, 3. So it's going to be all real numbers except positive and -3. So that's going to look something like this. We're going to go from -infinity to -3, and then we're going to go from -3 to 3 and pop over our hole and go from 3 then to infinity. The range of our function, we can have lots of different y values. Part of finding our range is finding that horizontal asymptote. So we found our vertical asymptote first. We found that at x equals -3. Our horizontal asymptote, that's the battle between 3x and x, and those guys simplify to 3. So that's y equals 3. So now our range can't include 3, but it also can't include our hole at the y value of 5/3. So our range is going to extend from -infinity to 5/3, and then from 5/3 to 3, and then from 3 to infinity. Close that parenthesis there. Then we're asked to explore the limits of our function, the limit as x approaches -infinity. What's happening to our graph as our x's get negative, but very large negative? We're approaching 3. We're approaching that horizontal asymptote. And that's what both of these top two questions are asking. What happens as x approaches positive infinity, our y value is going to 3. The limit as x approaches -3 from the left, so we're approaching our vertical asymptote of -3 from the left-hand side, and we can see that in our graph. As x approaches -3 from the left, we're heading up to positive infinity, and as x approaches -3 from the right-hand side, that graph is going down. We're going to negative infinity. And in the final question, what's the limit as x approaches 3 from the left? Well, this is a question of what's happening as we approach our hole, or our x value for our hole, or our y value is getting closer to 5/3. And as we approach 3 from the right, we're also approaching the y value of that same hole. That is also 5/3. In sample 4, we're given a function that's already factored. They ask us to use our calculator to complete the table. So hopefully you're familiar with the table function on your calculator, and I use the table set, or I use the calc function and find the value at these particular values. So we've got the factored form of our function here, and hopefully we can see that we're going to have a hole at x equals 4, and then we're also going to have a vertical asymptote at x equals -2, and after we cancel the x minus 4, as we have x plus 3 in the numerator, we're actually going to have an x-intercept at -3, 0 as well. So we've got a lot of good stuff here. So let's take a look and fill out this table. What I did is I went ahead first and I also FOILed this function, and this function FOILed was x squared minus x minus 12 all over x squared minus 2x minus 8. So then I could find some other things out as well. This is the battle between x squared. I know my horizontal asymptote is going to be at 1 because we're going to battle x squared over x squared, and my y-intercept is going to be at -12 over -8 if I put 0 in for x into my function. So if I wanted to find g of 0, I would see that's going to be at 3/2 if I'm looking at that correctly. So I put my multiplied out function. I could put the factors in, and that would work as well, but I just put the multiplied out function into my calculator, and I graphed that guy, and there I can see I've got my horizontal or my vertical asymptote here at -2. I've got my x-intercept, and I can't see my hole in here, but it is there. So I want to work on my table. I want to find x values of -500 and +500. So I'll go to my table set, so second table, and I'll set it at -500, and then I'll just go to table, and it'll tell me that the value that -500 is 0.998. And then if I wanted to do that again, I could do that again for 100. So back to table set, I'll do just 500 and table, and I'm at 1.002. So now I can answer question A on my chart. So as x approaches -500, it looks like g of x is getting closer and closer to 1. And as x approaches +500, g of x is also getting closer and closer to 1. So as x's get really, really big, what do we know about the end behavior? Well, we're heading closer and closer to 1. So this is a question of the horizontal asymptote, and it's that battle between x squared and x squared, and our function is approaching 1. So we take the highest degree value of x and simplify it. That's our horizontal asymptote. You can see that on our graph, or on our chart. Question B says, what happens as x approaches -2? And -2, remember, was that vertical asymptote from the left. And what happens as we approach -2 from the right? Well, we could look at our graph and see what happens, but I also can see in our chart when we approach -2 from the left-hand side, we're going to -infinity, and when we approach -2 from the right-hand side, our numbers are getting positive, really big. We're going to +infinity. So then we know x equals -2 is indeed the vertical asymptote of our function g of x. Question C asks what happens as x approaches 4 from the left and 4 from the right. So this is the question about our hole. So what happens as we approach our hole? What's that value? Well, we put 4 into our function, or remaining function, to find out exactly what it's approaching. And when we put 4 into our remaining function, we get 7/6. So the fact that as x approaches 4 from the left, we have 1.167, or 7/6. And as we approach 4 from the right, we also get 1.167 on our calculator, which is also 7/6. So I got that in my chart up here. And we can conclude about the behavior of the graph as x approaches 4. Well, that's the hole in our graph, and it's approaching 7/6. So we can say there's a hole at x equals 4 with a coordinate of 4, 7, 6. What do we know about g of 0? So what happens when we put 0 into our function? Well, we know that is the y-intercept. And when we put 0 in, we figured that out earlier, we get 12/8, or 3/2. So g of 0 is 3/2, and that's our y-intercept with a coordinate of 3/2. Find the real zeros of the function by simplifying the expression. Well, we did that already at the beginning. We saw that our x-intercept was at x equals -3, and we also saw that on the graph. So that's just an eyeball one. So our simplified function g of x is just x plus 3 over x plus 2. We set our numerator equal to 0 and solve, and that will tell us what our real zero is. So that's at x equals -3, or an x-intercept of -3, 0. And then finally, using the table and your results from part E, state the interval where g of x is greater than 0, or where it is positive, and where g of x is less than 0, or where is our function negative. We certainly can use the table. I find it easier to use the graph, so we'll cheat and take a look at our graph that we've already done. And that graph from our calculator looked something like this. We had a y-intercept at 3/2. We had a horizontal asymptote at 1. We had a vertical asymptote at -2. We had an x-intercept at -3. And we had our hole at 4, 7, 6. So where's our graph less than 0? Well, it was just between -3 and -2. So that's a little bit easier. So g of x is less than 0, just in that one range from -3 to -2. Now g of x is positive, greater than 0 in a few more places. It's positive all the way from -infinity to -3, non-inclusive. But then it's also positive, from our vertical asymptote at -2 all the way to the start of our hole at 4. So we would say from -2 to 4, but then we got to jump over our hole because that's not positive or negative, and then our y's are positive from 4 all the way out to positive infinity. So there's a good summary of that particular rational function, and you will get some more practice with this when I see you in class.